Other side, situation 2 is after dilution, because my units, of course, are going to be whatever volume units I put into that equation. So watch how I write this. Per 1 liter of solution. So here's an example. Let's say we've got 100 milliliters of a solution, and it's 2.5 molar concentration. Remember, capital M means molarity concentration. And we're going to take out 50 milliliters of this, and we're going to dump it over into this next beaker and add 50 milliliters of water. What do you think the new concentration is? Well, it's half of that, right? We took half of it out and we diluted it with that much water, and so our new concentration is 1.25 molar. 1.25 molar. Okay, so how do we do these concentrations? This is 2.5. All right, so let's look at a formula that will help you. So this is M1V1 equals M2V2. So it doesn't really matter which one is 1 and 2. So I would say this is the before dilution. I like to do that on the left. Doesn't really matter. And then the other side, situation 2, is after dilution. And so M is the molarity, concentration, and then V is the volume. Okay, and so let's look at an example of how I use this very simple equation. It's very much common sense. So here we've got a solution, and it's 2.5 molar, and we're going to dilute it. So I'm going to just drop in my, well, first of all, let's identify. This is, we'll say V1, and that is M1, and then this is V2, and what we're looking for is M2. Okay, so let's get that straight. And let's go ahead and drop these in. So 2.5 molar times 20 milliliters. Now some of you may say, whoa, shouldn't you convert that to liters? It's not going to really matter with this equation, and I'll show you in a second. It's fine if you want to convert to liters, that's fine. We don't know M2, so let's leave that as a variable. And then V2 is 250 milliliters. Okay, now check out the units here. Milliliters on both sides will cancel. So if we convert them to liters, they would cancel out. So it doesn't really matter. And then we'll just do the math. We've got to divide that 250 on the other side, and M2 is going to be, let's see, 0.20 molar. Okay, and so I like to go back there and check, does that make sense? We took a small amount and we diluted it. Did the concentration go down? Is it logical and reasonable? It sure is. So let's move on to another example. This time we've got a certain volume. Oh, we want to know the volume. So I'll say, what volume? I'll say V1. Doesn't really matter. M1. And then here is V2, and that is M2. Doesn't really matter which is which. So we've got 0.5 molar times, don't know the volume, equals 0.15 molar times 250 milliliters. And so if we solve for V1 in this case, we get 75 milliliters, because my units, of course, are going to be whatever volume units I put into that equation. And so does that make sense? Yes, it's reasonable. Okay, so let's look at one more problem, and this is how a lot of chemistry problems begin, and they give you concentrations and volumes. And I want you to know this. Remember that concentration, so molarity, and times liters is going to give you moles. Okay, so a lot of times when we have stoichiometry problems, we need moles of things, right? And sometimes you're not given moles, you're just given a volume of solution and its concentration, and you're going to have to figure out moles. So let me show you how I would work this problem. Well, one, I have a chemical reaction, so I know I'm going to relate two different things. So look at what we're looking for. Find the volume of acid that we need to react with a known volume and concentration of the calcium hydroxide. So I think I will start with the known. Okay, so I know I have 50 milliliters, which is 0.05 liters. Okay, I'm dealing with the calcium hydroxide right now because I have both the volume and the concentration. So times 0.30, that's my molarity. I'm going to write it as moles of calcium hydroxide per liter of solution. So if I stopped right here and multiplied, I would get moles of calcium hydroxide. Now go to the reaction and get a mole ratio. So let's get moles of calcium hydroxide. And then on the top, I'm going to moles of HCl. Okay, so go get your coefficients. There's a 2 and a 1. Okay, and so that is going to convert me over into HCl, which is where I'm going. Okay, so let's check our units here. Liters of solution, moles of calcium hydroxide. Okay, now I'm in moles of HCl. And where do I want to go? I want to go to volume. Well, what relates moles and volume? Well, it's this right here. It is the concentration of solution. So watch how I write this. I'm going to write this as, I want moles on the bottom. So I know it's 0.15 moles of HCl per 1 liter of solution. Okay, do you see how I did that? I took the molarity and I just flipped it upside down. All right, so I know I have, I want those moles to cancel when I multiply. So I flip it upside down so that moles will cancel. And what will I get? When I convert this thing and cancel all the units and multiply the numbers, I will get liters of HCl solution. So the answer here is 0.20 liters of hydrochloric acid solution. So that is how you use concentrations and volumes in a stoichiometry problem. I hope this helps you have great success in your homework.